We'll go ahead and kick this off here. And what we're actually going to be watching here is a new test agent spun up to generate this test. As you can see by default, this is actually a background operation. And so teams would not be tasked with watching the full generation create itself or the test create itself. Teams don't have to leverage their own local PC for the generation. So that means that we're not limited to kind of watching this work through. We can focus on other higher value tasks. But we'll go ahead and watch it for the demo purpose here. And we use these virtual machines for this execution as it is really the only way we can take advantage of this data-driven view. As I mentioned, for every step of this test, we're going to capture every element, regardless of whether we interact with them or not. And about 200 features, including those front-end DOM and CSS values, XPath, and IDs. We'll also capture things like network timing, console logs, and application data layer information to help actually support and drive this creation here. You can see it's actually starting by logging into Salesforce. And one interesting component here is you can see we're actually using our email reader to handle Salesforce's new multi-factor authentication requirements. So we can actually support these end-to-end flows across numerous different tabs and windows. As you can see, this email reader opened up in a new tab and is passing the information between these different sources. So if your team has workflows that span across both web UIs, APIs, databases, it's very simple to incorporate all of this within a single flow and pass or compare data across those different sources here. And then you'll see from here, all of the new steps will be generated using this agent and the prompt that we provided here. You can actually see this kind of train of thought going below the generation here. And we're going to be making this analysis for every single step of our test case as we're generating it. So you'll see, for example, we're navigating to the leads page from the home page. We're clicking on leads in the top navigation bar to create this lead. What we're going to be doing is looking at the application states, measuring the result, and then understanding what's needed to be generated to actually facilitate the rest of this end-to-end flow here. This is something that is actually not application-specific tuned. We do not need to actually train on new applications or go through a lengthy tagging process when interacting with new apps. This is actually what we call our zero-shot model, meaning we can take this and generate new tests against any new application, whether it's a SaaS application or a bespoke app. We're doing this because we have about a decade of enterprise application training data in place that allows us to then interact with new apps without any overhead from a training perspective. So it does enable teams with numerous different apps, and especially if they're building out new ones to support kind of a transition from legacy tools to modern frameworks. We can very quickly support this using this approach. And what's actually being created here, we are not generating scripts. There is no concept of code being created as we're actually creating this end-to-end flow. Instead, what we're actually doing is gathering machine learning data. We actually store this data as a JSON file behind the scenes, not something that teams ever have to interact with. So nobody needs to be a data scientist to use Functionize here. But what we're actually going to be able to do with that information is use it to very quickly add or adjust test steps, which I'll show in a moment. That same information will be used to self-heal our tests as we see application changes over time. And this is also information that we can use to autonomously diagnose any failures. So if we do see issues with our tests or our application, we can actually use our diagnostics agent, identify the root cause, and make the fix very quickly as opposed to having to manually identify the root cause of the test failure itself. So we can go ahead and let this generate in the background here. While this is generating, I'll very quickly bring up another test case, and we can talk a little bit about the process for supporting these tests once we have created them. So here's a test that we created using a very similar prompt earlier on here, creating a new lead in this case. And you can see the screenshots captured from this test generation earlier on today. And let's say for an example that we have a business requirement change or something in the application has been updated and we actually need to adjust our workflow to account for that. Maybe for a simple example, we have our new lead form here. And let's say we added a new field. Let's say this business phone number field in the top right. Traditionally, what teams would need to do is actually invoke the application, open up dev tools, and gather selectors to include in our test script. Or they would open up their record and playback tool and go through that process to get the application in the same state and record those new steps. Instead, what we can do here is we can actually leverage the machine learning data that we've already captured from this application state to very quickly add or adjust new test steps. So let's say, again, we want to target this business phone number field. What I can do here is I can come above the screenshot and you can see we have some of our test support options. Local edit and live debug actually allow us to invoke the app and use a record and playback style approach to add new steps. But what we also have here is quick add, which actually allows us to interact with the screenshot from the prior test run to add or adjust steps that we've actually have in place here. And you can see we have many of the same actions that we have available during our test creation process. So things like new input actions, click actions, verifications. In this case, I'll go ahead and select a new input. And what you'll notice here as I actually hover over the application, which is a really interesting insight into how we actually look at these apps and interact with them. You can actually see that every single element here has been identified, whether we interacted with it or not. So every dropdown, every element, every field has all been captured as part of this modeling. And we can use this information to very quickly add or adjust the expectations from this flow itself. So let's say, for an example, we have that phone number field. I can go ahead and click on that. I can add our new input. And I can insert that new test step. That test step will be picked up during the next execution of this run. And you can see we can do this in a matter of seconds as opposed to having to go through the lengthier process for maintaining these tests. And so quite a reduction in time as opposed to traditional approaches that I've seen in the market in my experience here. Of course, adapting our tests manually to these application changes is one side of things. Self-healing is also a tool that we have available to, again, greatly reduce the time teams typically spend maintaining tests release to release.